All right, here we go, folks. So this is the central limit theorem, example 5, part A. All right, we have a population that has a mean of 248, and we're told that the standard deviation is 3420. Now here's pretty important information here. It says right here that that original variable is normally distributed. All right, so that's pretty important to note. That would impact things as we move forward. All right, so anyway, here's the thing though. They're only choosing one store. And I guess you could consider that to be a sample of size 1. But I would simply be of the opinion that that's a population that we were told is normally distributed. We have its mean and we have its standard deviation. I don't really see the need to jump over to X bar because we're only sampling one store. I guess if you did this, you could do sigma over the square root of 1. It's still going to be sigma. So I guess my point would be, if you have a normally distributed population and you're only sampling 1, just do it like we did on assignment number 17. All right? So I wouldn't see the need to jump over on this one. And so here we go. X, I don't see X bar going on here. So we're just going to say, what's the probability that X, and I think it gives us another one of those between kind of questions, 187 and 254. All right, and then we draw our bell curve. We were told it was normally distributed at the beginning, remember. All right, so 248, and I would note that 187 is below that, and 254 is above. And we're talking about that area in between. And again, apologies if I would normally be writing bigger than this, but again, it's just the board space is at such a premium here. So anyway, and it's just do it like, this is assignment 17 all over again. So then what we would do at this point would be to standardize both of those. 187 minus 248 over 3420. Boom. All right. Went ahead and did the arithmetic on that one, and that one turns out to be negative 1.78. And then, and look, that's below the mean. Let's go ahead and put that on the new picture here. So standard normal bell curve, 0 in the middle. 187 translates to negative 1.78. All right, the 254 is above the mean. It better end up being a positive z-score, and let's confirm that. So x minus mu over sigma, and that one standardizes to 0.18 positive, notice. And again, we're looking for that area in between. The question said in between two scores. So then this would of course be the time when we go to the standard normal and look up both of those z-scores. And the 1.78 will give us an area from the table. Again, I went and looked that up. And if I am reading this correctly, that should be 0.4625. And then we look up the other one. And always remember, this table gives you that middle sliver. So when we look up 0.18, that gives us a middle sliver of 0.0714. And my hope would be you would look at that picture and, as we did on assignment 16, see how these keep building upon each other. If we would take that middle sliver and add that middle sliver, we'll get that total area between them, which in this case is 0.5339. There you go, there's that one. So the thing that was somewhat different about that one again was that if you only sample one store, one item from your population, if you're told it's normal to begin with, you're good to go. Just do it like we did before. All right, one more, we'll come back and do 5B.